Okay guys, hopefully by now you've watched the video one on the AND law, which is basically your multiplication law. If you want two events to happen, this and this, then it's the probability of event 1 multiplied by the probability of event 2. And we talked about those events being independent. We're now going to look at the OR rule, to either this event happening or this event happening. So it could be one event, but with multiple things we're allowing to happen within that event, as long as those events are mutually exclusive. Don't get hung up on that. All that means is can't happen at the same time. For example, if I was rolling a dice and to be the winner, I said you can either roll a 5 or you can roll an odd number. Well, 5 is an odd number, so those two events are not mutually exclusive. They can happen at the same time. Again, we're not going to go into too much detail on that. That's something for maybe at A level and not now. However, let's look at two examples. There are 3 red, 4 black, and 5 blue cubes in a bag. The cube is selected at random. What is the probability of selecting a red or a blue cube? So there's the bag. It's got the 3 red, the 4 black, and 5 blue cubes in it. Okay. And since there are 8 cubes that are red or blue out of a total of 12 cubes, the answer must be 8 out of 12. So the probability of red or blue equals 8 out of 12. Note that we could have written down the individual probabilities and added them to get the same answer, like so. The probability of red or blue is equal to the probability of red add the probability of blue. 3 out of 12 add 5 out of 12 equals 8 out of 12. Example 2. Find the probability of selecting an ace or a king from a pack of 52 cards. Here are the cards. 13 hearts, 13 clubs, 13 diamonds, and 13 spades. Simply by counting the outcomes needed. So for example, there are 4 aces I can see in that list, and there are 4 kings. The answer is 8 out of 52. So the probability of me getting an ace or a king, there are 8 of them out of 52. Or, as before in example 1, we get the same answer by adding the individual probabilities. So the probability of an ace or king is equal to the probability of an ace, add the probability of a king, so 4 out of 52, add 4 out of 52, which is 8 out of 52. So let's remind ourselves what I said about mutually exclusive events. In the 2 examples, the events that occurred could not have happened at the same time. In question 1, a red and a blue die could not have been chosen at the same time. In example 2, an ace and a king could not have been chosen at the same time. And as we just said, events that can happen at the same time are called mutually exclusive. But again, I don't want you to overly think that, okay? Because when we do examples and when we do the GCSE, they will give you mutually exclusive events, okay? However, when events are mutually exclusive, we can always add the probabilities. So this is the OR law. For mutually exclusive events, the probability of A or B happening is equal to the probability of event A add the probability of event B. To illustrate this a bit better, let's look at 3 questions, again based on the deck of cards. Question A, the probability of getting a 3 or a 7 or a king with picking 1 card. B, the probability of getting a heart or a diamond or a spade. And C, the probability of getting a diamond or an ace, which we'll use to highlight the problem of events that are not mutually exclusive when we get there. Starting with A. There are 4 out of 52 threes, 4 out of 52 sevens, and 4 out of 52 kings. So by adding them together, we get 12 out of 52, which simplifies to 3 over 13. For B, there are 13 diamonds, 13 hearts, and 13 spades. So each of the separate probabilities here is 13 out of 52, but added together we get 39 out of 52, again, which simplifies to 3/4. But now consider the problem with C. Again, don't worry about this. This is not something that will happen, but it's interesting for you to see the problems here. These events are not mutually exclusive. Okay, there are 13 diamonds and 4 aces. So using our rule, 13 out of 52, add 4 out of 52 would normally be 17 out of 52. However, the ace of diamonds is both a diamond and an ace. So by using the rule, we're counting that ace twice. We're counting it in the 4 aces, but we're also counting it in the 13 diamonds. So in fact, there are not 17 out of 52 cards that abide by this rule that we're looking for. There are only 16 out of 52, which is 4 out of 13. And the rule hasn't worked because the events are not mutually exclusive. Again, do not worry about this now. Let's recap both the rules, the AND rule and the OR rule, and look at a question where they could be applied together. Okay, so let's look at 2 dice which are rolled. 2 independent events, okay? So the outcome on dice 1 won't affect the outcome on dice 2, and by nature, if they're independent, they're also going to be mutually exclusive because they can't happen together, okay? So let's have a look first of all, the probability that both numbers are 5. This is the AND rule. We want a 5 on dice 1 and a 5 on dice 2. Well, on dice 1, the probability of getting a 5 is 1 out of 6. And on dice 2, the probability is also 1 out of 6. And the AND rule says that we simply multiply this. So the chances of getting 2 5s are 1 out of 36. In B, we want a 4 followed by a 5. Again, the probability of getting a 4 on dice 1 is 1 out of 6. And the probability of getting a 5 on dice 2 is 1 out of 6. And the AND rule says that we multiply, so it's the same probability. In fact, all the probabilities when we roll 2 dice are 1 out of 36. All the outcomes are 1 out of 36. There are 36 outcomes when we roll 2 dice. However, what is the probability that I roll a 4 and a 5, but in any order? Okay, that could be a 4 and a 5, or it could be a 5 and a 4. Now, based on what I just said, a 4 and a 5 has a probability of 1 out of 36, but a 5 and a 4 also would have a probability of 1 out of 36 by the same logic. But because we're allowing either or to happen, we need to add these together. So, my apologies, I'm running out of room. My probability here would be 2 out of 36, which we could simplify by halving that to 1 out of 18. And finally, what about the sum of the two numbers is 4? Oh, right. How could I get a sum of 4? Well, I could have a 1 and a 3, or I could have a 3 and a 1, but there is another way to make 4, or a 2 and a 2. 3 different ways to get a sum of 4 with my 2 dice. This could happen, or this, or this. Well, using the AND rule, we know that each one of these is 1 out of 36. But using the OR rule, we know that we've got to add them together. This time giving me 3 out of 36, which would simplify if we divide them both by 3 to 1 over 12. And that is it. The AND rule and the OR rule, mainly used, I would say, in dice or coin questions. So looking at 1 out of 6 or 2 dice making 1 out of 36. And on a coin, heads and tails, each probability a half. But if we look at 2 coins, that would each probability would be 1 out of 4, a half times a half. Maybe even a combination of 1 dice and 1 coin. Each probability on the dice, 1 out of 6. Each one on the coin, 1 out of 2. So if we do both at the same time, roll a dice and toss a coin, each outcome, for example, a 1 with a heads or a 2 with a heads, would have a probability of 1 out of 12, which is 1 out of 6 times 1 out of 2. Now it's your chance to have a look at these 2 rules in some past paper questions. Bye-bye.